Welcome to this training video, where we will explore the fundamental concepts of value type objects and their crucial differences from classes in programming. Understanding these distinctions is vital for writing efficient and bug-free code, especially for beginners navigating the world of software development. Let's begin by defining value type objects. These types directly hold their data, meaning when you assign a value type variable to another, a complete copy of the data is made. Common examples include primitive data types like integers, floating point numbers, and booleans. In some languages, structures or structs also fall under the category of value types. Now, let's turn our attention to classes, which are also known as reference types. Unlike value types, classes do not directly store their data. Instead, they hold a reference or a memory address to where the actual data is stored. When you assign a class instance, you are copying this reference, not the data itself. Typical examples of classes include custom objects you define, arrays, and often strings, depending on the programming language you're using. One of the most significant differences lies in memory allocation. Value types are typically stored on the stack, which is a fast and efficient memory region. Classes, on the other hand, are stored on the heap. The heap is a larger, more flexible memory area, but accessing data there can be slightly slower due to indirection. Consider the assignment behavior. When you assign one value type variable to another, you get two independent copies of the data. Changing one copy will not affect the other. This behavior ensures data isolation and predictability. However, with classes, assigning one variable to another means both variables now point to the exact same location in memory. Consequently, if you modify the data through one variable, the changes will be reflected when you access it through the other variable. This shared reference behavior is crucial to understand, as it can lead to unexpected side effects if not managed well. Another key difference is mutability. Value types are often immutable, meaning their state cannot be changed after creation. If you need to modify a value type, you typically create a new instance with the desired changes. Classes, conversely, are generally immutable. Their internal state can be changed at any time through their methods or properties. This mutability allows for flexible object manipulation, but also requires careful handling to avoid unintended modifications. When should you choose a value type? They are ideal for small, simple data structures that represent a single value, like a point or a color. Use them when you need independent copies of data and when performance is critical due to their stack allocation. Classes are best suited for complex objects that encapsulate behavior and state, especially when you need to share data among different parts of your application. They are perfect for modeling real-world entities like users, products, or database connections. Regarding performance, value types generally offer better performance for small data due to direct memory access and stack allocation. Classes, with their heap allocation and reference-based access, might incur a slight overhead, but this is often negligible for larger, more complex objects. A helpful tip for beginners. Always consider the intended use and behavior of your data when deciding between a value type and a class. Another important tip. Remember that specific implementations can vary significantly between programming languages. Always consult your language's documentation to understand its particular nuances regarding value and reference types. In summary, value types store data directly and are copied by value, while classes store references and are copied by reference. Value types reside on the stack and are often immutable, offering performance benefits for small data. Classes live on the heap, are generally mutable, and are ideal for complex, shared objects. Mastering these concepts will significantly enhance your programming skills and help you build more robust and efficient applications. Thank you for watching, and we encourage you to continue exploring these foundational topics in your programming journey.